Good morning, one and all, and welcome to the video. This weekend, we are gonna explore about Dask. So this is gonna be a complete series where you will learn about Dask in Python. So let's get started. My name is Saumil Shah. I'm a full stack software engineer. I recently completed my double masters, and I love to teach people on YouTube. So let's explore Dask with me. So let's read a couple of definition first. So Dask provides advanced parallelism for analytics, enabling performance at a scale for tools you love. So let's read a couple of things, and then I have a very nice notebook for you where I would be actually walking through all of these tutorials and all the functions and how you can do all of that. If you're really excited to learn, let's get started. Start up your Jupyter notebook, and first let's read a couple of definitions before getting started. So quickly, let me just make sure that everything is okay. So first of all, I'm going to read a couple of definitions. So first of all, okay, integrate with existing projects, so that's pretty easy. Built in with a broader community. NumPy, Pandas, Scikit-learn. So Dask array scales NumPy workflows, enabling multi-dimensional data analysis in earth science, satellite imagery, genomics, biomedical applications, and machine learning algorithm. So it does like distributed computing on a NumPy arrays as well as Pandas arrays. So instead of using pandas, I highly recommend you to use Dask, because when you go to industries, at a point pandas won't work because the amount of data you would be dealing with would be gigabytes and petabytes. Pandas is not going to work. You definitely want to scale your distribute your load among multiple machines. So that is when you would use Dask, right? So you can use to train models. You can use Dask to do data science and stuff like that. It's the syntax is very familiar, similar to pandas, so you don't have to learn anything up. So you can scale up to clusters, as you can see, as many clusters if you want to scale, you can do that. So Dask schedule scales for thousands of nodes and clusters, and its algorithms have been tested on some of the largest supercomputers in the world. Okay, so that's a big thing, but you don't need to a massive cluster to get started. Dask ships schedule designed for use on personal machines. Many people use Dask today, scale computation on their laptop and the multiple cores. So basically, you can use it on your computer as well. That makes sense. So who's powered by Dask is basically Pandas, NumPy, Scikit-learn, and you can see the list goes on. I mean, it's just crazy. So it's a very popular library. I would highly encourage, please, learn this. It's supported by Nvidia. They make GPUs. Most of the GPUs are made. Best GPUs are built by Nvidia. Anaconda is there. Capital One, Coiled. So these are some of the companies who are supporting Dask. Okay, Alexa, stop. Okay, sorry about that. So that's Dask. So now let's get some hands dirty and actually try out coding in Dask. Okay, so let's get started. So roll up your Jupyter notebook. As I said, I would try my best to, we would go step by step, slowly, make sure that everything, we learn everything. Okay, so let me actually add a header, and give me one more second while we prepare, because this entire documentation would be also available on my blog, so you could come and read again whenever you want at your own time. So first of all, we need to install Dask, right? So that's the first thing. Usually I had some problems also in installing. So these are the steps I followed and it works fine. Pip install Dask, and you want to make sure you have Cloud Pickle. You want to make sure you have Dask data frame and Dask complete. So make sure to install all of these commands. As I said, everything is there in the description section below, so you shouldn't be having any sort of problems. Once you install that, you could verify by using this command pip show Dask. The exclamation mark basically tells the Jupyter notebook to run it in a shell mode. Let me make sure it's recording. Okay, it's perfect. So yeah, it might take a while, but yeah, this is the version I'm using. Dask. My specs, I guess I got to change my number. So yeah, so I'm using the version this is the Dask version I'm using. So just in case, if you're following along, yeah. So the first thing what we need to do in order to learn Dask is, first of all, we need to define a couple of imports, right? So first of all, we'll be doing a small data science project. I mean, we just, I'll teach you very basic fundamentals. So first of all, what we need to do is basically from Dask distributed import client, and we need to import Dask data frame. We need to make sure we have NumPy and we have multiprocessing enabled from Dask. All right, let's get rolling, man. So first of all, I'm gonna actually print the list of files I have in my directory using list dirs. So I'm gonna use a Netflix data set. It's a pretty small data, not a big data. If you want to print the size of the data, it's pretty easy. You could just say os.path.get size in Python, and you could divide by 1024 to the power 3. That would give you the size in gigabytes. So once you do that, what we need to do is, first of all, we need to create a cluster, or basically we need to create a client. I'm gonna run the task on my laptop. So first of all, you can say n workers as 3. That means you want 3 workers, threads per worker. So each worker should have how many threads. So I'm saying, hey, could you please actually give me one, threads for each workers? Memory limit. I'm saying that although my computer has 6 gigabytes, I'm saying that, hey, you are only supposed to take 2 GB of RAM. I mean, so for 3 workers, you're gonna consume like 6 gigabit maximum. You are not supposed to take more than that. So as soon as I run this, it should spin up a client. So if you try to print the client here, so yeah, it basically tells you that cluster, this is my cluster. It has workers at 3, cores 3. I'm using 3 cores, memory is 6 gigabytes. One beautiful thing I like about this is basically it also provides you a nice dashboard. So basically, when you are performing certain like operations, you can see your task is being distributed. So yeah, you can come here in status, worker, task system. You can of course explore more. I don't want to go much in detail about the UI, but let's focus more on the core functionality. Okay, so first thing for us is basically how do we read a CSV file, right? So we want to read a file. So read. So I'm just basically writing, what do you call that? I mean, I'm writing comments. So because when you read it, it's easier for you. Otherwise, if I just write everything in one line, makes no sense, right? So you would say task dot read CSV. This would actually read the CSV as a task data frame. So if you say dd, and if you run this, it's gonna print something like this. Okay. Now, if you want to grab the first 5 rows, you could use the word head. Similar, you have it in what do you call that? Pandas, right? So I'm just gonna say .1 because I just want to do the one, and you could also use the word tail. This would show you the last element, as I said. Nothing fancy here. Same thing, you know. By the way, you could also say the shape. That would give you the shape of the Dask data frame. Remember, it's not showing you the rows; it's giving you a delayed. I'll tell you what that is in as we progress on the tutorial. But it's telling you there are like 12 columns, and the number of rows is, it can be massive. So it's not gonna. So we'll come to that. Don't worry. Now, so now I want to teach you guys is basically how. So selecting columns in Dask is actually very easy. First of all, if you want to print the list of columns, yeah, you could do something like this: task.columns, dd.columns. It would basically tell you all the list of columns you have, right? Now, if you want to select a column, let's say you want to select a column, right? So you could use a task and the bracket operator to select the column, and you can use the word head. That works fine. But if you want to use the dot operator, you could definitely use that. Nobody's stopping you. So you could say something like show id dot head. This works fine also. So both of them are valid. It works, solves the purpose. But if you want to select multiple, as I said, multiple columns, you would use the bracket operator, and then inside that you want to say again a bracket operator, and then you want to say, like, let's say I want to grab the title, and so this is how you would do that. Selecting multiple columns is how you would do that in Dask. That makes sense. If you want to filter out certain rows based on certain conditions, so you could just use simple. I mean, you could say task dd, and you want to filter out, right? So you want to say task, and hey, I want to filter out all the records where the show id is equal to. I'll tell you where the true power comes in computation in Dask actually. So I mean, I can just say head. So it's gonna oops, says that show id is not defined. I mean, that makes sense because it has to be in a quotes. So okay, so that works fine. If you want to select particular columns only, I guess you could yeah, you could say something like this. You just want to grab the type, I guess, because that was in pandas, but I guess Dask also supports that. So you can see, I mean, most of the functionality is there. I mean, you don't have to worry, you don't have to learn a new language. It's just you gotta use a library. Okay, now I'll tell you where the true power comes. So let's try to apply some functions and see. So how do you apply functions in Dask? So oh, I guess I have a typo. Okay, so we gotta apply a function. So let's say I have a very simple function called as an upper function. Basically applies a transformation, right? So couple of ways to do that. You use the word map here, okay? You don't say apply because in pandas you say apply, but in Dask you say the word map. So you select the column and then you say up dot map and then you just say the name of the function that you want to map, right? It's pretty straightforward. And then again, I'm storing back it in the title column, right? So if I run this, nothing fancy here, it's same thing. So now I'm just printing that, so title.head. Now everything should be capital. Okay, that makes sense. Okay, it's pretty easy. But if you want to compute this on a distributed cluster, that means if you have multiple computers and you want to compute, let's say you're reading a gigabyte or petabyte of data and you want to process these some kind of an, you want to apply some kind of a transformation, you could of course apply, do it on a cluster as well. So you can let me show you an example. So apply so if you want to leverage that purposes, I'm thinking, should I just directly show you that? Yeah, I mean, it's fine. So first of all, what you gotta do is, I mean, actually I'm doing a list comprehension, but so here's the thing. Bear with me, okay? This is a list comprehension. I just wrote everything in one line. I mean, there's no need you have to do this, but yeah. So for result in client.map, so I'm just saying that, hey, client was the we create a client, a distributed, it tells you about the workers and the cores and the memory. So I'm saying that, hey, client.map, I want to map an upper function there. Okay, so I'm saying that, hey, could you use this function, and I'm passing title to that. Okay, I'm saying that, hey, pass me the title. Okay, and then I'm saying result. So when you say result, what it does is basically, so first of all, even if before doing that, let me step back, otherwise you'll be like, oh, what's going on. Okay, so let's actually store this in a variable and show you. How about that? We do that, it should be fine. So yeah, that's a good example. That's a good way to show you what's happening behind the scenes. First of all, I need to make sure because you guys can see, because yeah, okay, let me yeah. So yeah, when I run this, what happens is, if you see this, a futures some object, right? So it's basically, that makes sense because what it does is basically it distributes that load among different clusters. So it's kind of a thread. So it's creating a thread or a pull, however you want to say. Okay, so it creates a thread, and now you gotta wait. You gotta wait for those threads to finish, right? So you call the word dot result. So I'm gonna grab just the first one. I'm just gonna show you. So it's a future object. If you want to see if it's finished, so you see status is finished. So what you gotta do is, you could say, if you want to grab the result. Okay, as I said, I'm just showing you the concept. You could use the word result, and that would actually give you the result. But the same. So what I did is basically I wrote everything in one line. I mean, I don't wanna. I mean, I just did a list comprehension because I know what I'm doing. So essentially what I want to do is I wanted to do some heavy computation, which I wanted to distribute that across clusters. So I did a list comprehension, and I'm saying that, hey, dot result, so wait for that result of blah blah blah. So I did that. It's gonna work. And then if you want to store it on a new column, right? If you want to say you did some computation, and after that computation you have to store that result somewhere in a new column, right? So I'll show you how you do that. Give me one sec. It's gonna take a while to process these, but yeah. Yeah, usually, what you wanna do is, I mean, it's fine. I mean, yeah, it's the same thing. I mean, you wanna create this object, and then you wanna call dot result. So you wanna do it on a multiple lines, but it's fine. Whatever. So now we have the results in that variable temp. So I'm just gonna print one of them. I'm not gonna print, otherwise it's gonna crash my fucking kernel. So yeah, that makes sense. Okay, so now if you want to store that again in a column, right? If you use like something, what I'm saying, guys, is this is not gonna work. So if you say like store this result in this way, it's not gonna work. It's gonna throw an error. Okay, it's not pandas. So what you gotta do is you gotta convert this into a numpy array first. So I'm just doing that, temp. So because converting it to a numpy array, and then I'm basically using the Dask array. So I'm saying that from array and I'm passing that numpy array. So I could do that in a one line, of course, and I would do that in a one line. So, okay. So basically, first of all, you gotta convert into a numpy array or numpy array, blah, blah, blah. And then you gotta use Dask from array. And I'm storing it in a variable. Okay. So once I do that, I wanna just show you how it looks like. I'm gonna use the first one, and then I'm gonna explain you more concepts in Dask. So yeah, it's basically as I said, Dask array, blah blah blah. So now what you want to do is you could do something like this. This will work now. So something like that, and then if you do dd.head, you would have that random random index created. But yeah, if you do the other way around, it's not gonna work. It's gonna give you error. I tried it. That's why I'm telling you. Okay. So yeah, that's that. Now let's I taught you about very basic of task like filtering, applying a functions and transformations. Now, if you want to use Dask for async programming as well, you can, of course, pretty much use. So let me, some basics of Dask. Now, this is not related to, as I said, like data science, but in general, if you want to distribute your load or if you want to do some computation, it's a very good. So let me just show you basics of Dask. Okay, so what I'm saying is, okay, let me show you something. I mean, when you guys will understand when I show you something, right? So we have a function increment. He sleeps for 1 second, and then he, increments the variable. We have a function add, and it takes a 2 number. Now, what do you think will happen here? So I'm calling the function increment. I'm calling the function again increment, and then I'm adding the number. So calling this function increment should take 1 second, then again 1 second, 2 seconds, and then to compute again 1 second. So total 3 seconds, right? I mean, makes sense. It has to take 3 seconds. I mean, exactly. So, but what you could do is you could parallelize this. You could actually, as I said, that's what the Dask does behind the scenes. So let me show you what I mean by that. So you could parallelize this. So what you could do is you can say from Dask import delayed. So as I said, from Dask import delayed, and I'm saying delayed, and then inside you specify the name of the function, okay? And then you give the arguments the way you want to give. So doing that, what do you think would this task, what do you think that this would, how much time do you think this would take? So let's do this guy right here. Okay, so I'm gonna do that. Let's see how much it takes. Oh, wait, what did I do? Magic function time. Oh, yeah, time it. You gotta import that, so it's fine. So if you do that, I mean, hold on. I know what it's going on. So it took 2 seconds, less than that. The reason it took 2 seconds is because it distributed among us multiple. It does not have to wait synchronously. Let's try out again. So that one takes 3 seconds. 1, 2, 3. Okay. And this one should take less than that, the computation. So you can see 2 seconds. So it's much more faster, right? You could speed up your functions. So as I said, so whatever functions you want to execute, you would say the word delayed, right? And remember this function z, he calls the add function and he passes the value from x and y. So he has to wait until x and y is complete. So all of that, queues and all behind the scenes, it takes care of you. You don't have to worry. Just call dot compute on that. That's all you gotta do. That's it. So it's that easy. Again, I want to show you some more exercise on parallelizing loops now. And as I said, this entire Jupyter notebook is there on the blog. I would leave the links in the description, so you don't have to worry about anything. So yeah, this is a loop, a simple list, right? So let's do a simple computation, and I'll show you how you can parallelize that. So my computer is lagging, man. Okay, so nothing fancy. Let's define the function here. I don't want to. So yeah, let's call this one right here. Because I don't want to. Oh man. Okay, whatever. So yeah, we have this function. Now what I'm doing is essentially is I'm looping over the data and I'm incrementing each variable and then appending it to an array, right? And then I'm computing the sum. I mean, Yes, you could do that, but it's a very tedious. I mean, it's gonna take like 8 seconds. I guess like one, two, four, five, six, 7, 8. Perfect. 8 seconds, yeah. Because you have 8 elements and each one takes 1 second, so 8 seconds, right? How do I speed up? Like you have loops, right? So what Dask says that guys, it's fine. You use this, okay, no problem. But if you want to parallelize this, just use the word delayed. All I'm saying is, okay, let me show you one more example there. So same example, right? So instead of increment, I just added the word delayed, okay? And okay, so you are appending into the result, and then you wanna the result is also delayed, okay? Because you performing some stuff, right? So I'm saying delayed, then sum, and the sum is a function, right? Because and then you're passing the argument that is a result, right? And then when you want to actually get the result, you say dot compute. So this would distribute your work across multiple, whatever you want to say, workers or cluster or blah blah blah. Same thing. So if you do this one, let's see how much it takes. So before computing delay, so you can see 44, and it takes 3.25 seconds. That is great. I mean, say 8 to 3, it's amazing. So what I'm saying is, if you're iterating over some data and you're doing some computation, do that, it's fine. I'm not saying not to do, but use the word delayed there, and then just do a compute on that function. So that way you could speed up these kind of methods or stuff in program, right? Because think about it, when you have a function, what you do is usually we write a queue, we launch in threading, we launch everything as a thread, and then you do dot join on those stuff. So it's the same thing, but it takes care of all of that behind the scene. You don't have to write all of that, but it's good to know, right? It's always good to know the old school way, um okay. So now let's say some people don't like this delayed. You're like, what the hell, I mean, but you could also use decorator decorator way. So if you don't like this, let me actually write there. So if come on man, if you want to use decorators, I mean, yeah, of course, nobody's stopping you to use that, okay. Let's do the same thing with the decorator. Just gonna copy paste my snippets. So from Dask delayed, now I'm using the word delayed at the function. So when you do that, you don't have to write delayed in the function. If you don't like that syntax, if you like more decorator syntax, I mean, of course, sure, do that. I mean, nobody's stopping you. As I said, dot compute, still again 2 seconds, so that works fine. So I want to like conclude the video right here. Hopefully you guys did enjoy these tutorials, and if you did really enjoy this tutorial, please let me know by doing that in the comment section. It takes a lot of effort to make one video. Trust me, I gotta practice myself, I gotta learn, and then I have to teach you guys. But yeah, thank you so much for love, thank you so much for support. Hope you guys have enjoyed it. If so, do give a like, and if you have any more questions, list your question in the comments, and I would be very happy to assist you. Once again, thank you, keep smiling.